Good morning, grade 2s. We are going to look at arrays today. Arrays is a part of multiplication, and it's actually a wonderful tool that we have to make things a little bit easier for us. So I'm going to explain it to the best of my ability today, and then I want you to try out a few of your own. This is actually a really fun way to do multiplication, and it helps us. It helps us to see why we can swap the factors around. But as always, before we start and get into the other more difficult things, let's do our skip counting. I'm concentrating more on counting in 3s and 4s this term because we haven't done that before. The 2s, 5s and 10s we've done in grade 1, we've done in the first term in grade 2, and now we're going to just focus a little bit more on the 3s and the 4s. So let's go. All right, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, 48, 51, 54, 57, 60, 63, 66, 69, 72, 75, 78, 81, 84, 87, 90, 93, 96, 99, 102, 105, 108, 111, 114, 117, 120, 123, 126, 129, 132, 135, 138, 141, 144, 147, 150, 153, 156, 159, 162, 165, 168, 171, 174, 177, 180. Yes, we've gone a long way today. We've counted all the way up to 180 in 3s. We're going to count backwards in 4s from 60. So let's go. 56, 52, 48, 44, 40, 36, 32, 28, 24, 20, 16, 12, 8, 4, 0. That's very good. I did teach you a trick a little bit earlier on about how to times in 3s. So I said any number multiplied, how to times in 10s. So this is what we are going to revise today. Every number you multiply with 10 is obviously that number and a 0. So one group of 10 is 10. Two groups of 10 is 20. Three groups of 10 is 30. Four groups of 10 is 40. Okay, and that's how it carries on. So let's quickly do the 10 times table. 0 times 10, 0 groups of 10 is 10. 3 times 10, 30. 12 times 10, add the 0 to the 12, 120. 2 times 10, 20. 4 times 10, 40. 6 times 10, 60. 5 times 10, 50. 9 times 10, 90. 1 times 10, 10. 3 times 10, 30. 1 times 10, 10. 11 times 10 would obviously be 11 and a 0, 110. 0 times 10 is 0. 10 times 10 is 100. 7 times 10 is 70. And 8 times 10 is 80. Another concept we're looking at this week is halving. We are revising halving, and I'm quickly going to go over what halving is, and we are also going to share things equally into groups as we see. Halving means to share equally into two parts. Good. So So we have to share things. I have things here, and we are going to count those things. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I have 18 things. We can also call them small rectangles. Now pretend you're out on the sports field and you guys are dividing yourselves into two groups that are going to compete against each other. Then we would go like this. I would take two. I would say one in group 2, one for this group. Let's go one first. One for 1, one for 2. We literally are sharing equally into the two groups. Whatever I put in at 1, I've got to put in at 2 as well. You can see that when we halve, things must be exactly the same in the two groups. And I'm doing it here to show you how fair we are. If I put 1 there, immediately I put 1 on that side as well. And 1 there and 1 there. And now I've put them in an array for you, so it's easy to add them up. It's 3, 6, 9, 3, 6, 9. I have divided 18 into 2 equal parts, which made it 9 on this side and 9 on that side. And that is, grade 2s, what halving means. To share equally into 2 parts. That is very, very good. And now onto arrays. Now arrays has everything to do with rows. Rows has to do with the way the farmers would plow their lands and sow their seeds so that they can maximize the way they water and whichever reasons they have for that. But when we think about rows, we automatically think about farmlands. That's what we do here in South Africa. I know they have the most amazing shapes these days in which they plant their seeds. But for this lesson, a row is a straight line, and a row moves from the left to the right. From the left to the right. That is a row. A column is something that comes down. As you can see, the columns in front of this ancient building, they are things that go down. So arrays go horizontal, columns move vertical. We are talking about arrays, multiplication, and also factors. I want you to show you today how we can swap the factors around in multiplication, and one of the best ways to see that is through arrays. Here's a very simple example. I've got these blocks here. If we count them carefully, you will see that I have 1, 2, 3, 4 going across in each row. There's 4 in that row, and there's 4 in that row. Coming down, there's 3 in this row, 1, 2, 3 in column, 1, 2, 3 in this column, 1, 2, 3 in this column. Now I have one of 2 choices. I can say 4 plus 4 plus 4. Then I've counted everything in the rows across. Equals 4 plus 4 is 8, plus 4 is 12. Right. So what do we see? 1, 2, 3 4s. So we say this is 3 rows of 4, and that equals to 12. We can check 4, 8, 12. Right. The other way around would also be true. We could say this is 3 plus 3 plus 3 plus 3. And right in the beginning of multiplication, I taught you that it is actually repeated addition, which we just write in a shorter way, of which the first number tells us how many of each group there are, and the second number always tells us what we are counting in. Right, so 1, 2, 3, 4, 3, 6, 9, 12. We have been counting in 3, so that is easy for you to do. And now we can say there are how many? 1, 2, 3, 4. There are 1, 2, 3, 4 columns. There are 4 threes. 4 times 3. And the same answer comes up 12. So 3 times 4 equals 12. And 4 times 3 equals 12 as well. Let me show you yet another example. Here's an easy one for us to do. An easy little one. Let's see if I can erase this. Sometimes this board is a little bit stubborn and I struggle to erase the sums nicely. But we are going to just carry on quickly and pretend some of the stuff at the bottom is not there. Good. So let's do that. So we have 2, 1, 2 in this row. We have 2 in that row. Those are the rows. In the columns coming down, I also have 2 and I also have 2. So in this case, the factors are the numbers in a times sum. Are not interchangeable. They are, but they are just the same all along. So we can either say 2 plus 2 equals 4, or we can say 2, there's 2 rows, there's 2 2's, 2 times 2 equals 4. And if we add up the columns, we will get to exactly the same sum. So we're not going to do that now. That is another example. Here's yet another example for you to see of an array with rows and columns. And we're going to do it like that. There we go. Try my best to take that off quickly. And there we go. Right, so now we have rows, 1, 2, 3 in that row, 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 1, 2, 3 in this row. The columns coming down, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. There we go. So now I have options. I can either say, yes, 3 plus 3 plus 3 plus 3 equals 3 plus 3 plus 3 plus 3 plus 3. 1, 2, 3, 4, 5 3s. So let's write it down. 3 plus 3 plus 3 plus 3 plus 3 equals 15. How many 3's do we have? 1, 2, 3, 4, 5. We have 5 groups of 3. 5 rows of 3 in each, and that gives us 15. Here's another interesting one. We have 3 5's at the bottom here. So we could also say 5 plus 5 plus 5. 5 plus 5 is 10, plus 5 is 15. I know you knew that answer. How many 5's do I have? 1, 2, 3. So I'm going to say 3 times 5 equals 15. And I've made a few more of these examples for you to see. I'm going to hold this part closer to the camera so that you can see that easily. There we have a row of 3 and a row of 3. Okay, so we have 3 plus 3 equals 6. 2 times 3 equals 6. Here the columns show 2, 2 and 2, which means 2 plus 2 plus 2 equals 6. And now we have 3 2's, which means 3 times 2 equals 6. So the factors are interchangeable. They can change around. 2 times 3 equals 6, but also 3 times 2 equals 6. Here we have rows of 4. So we have 4, 4, and 4. 4 plus 4 plus 4 equals 12, but at the same token, 3 times 4 equals 12. 3 plus 3 plus 3 plus 3 equals 12. 4 times 3 equals 12. There you can see 1, 2, 3, 4 threes, 4 times 3. So 3 times 4 equals 12, and 4 times 3 equals 12 as well. And that is all about the fun we have with arrays and swapping our factors in the sums around. Remember, if you don't know 3 times 4, but you already know 4 times 3, then you can always swap it around in your mind and still give the answer. It's about being quick and it's about being accurate. Have a lovely day. I'll see you next time.